Hi, thank you very much for having me. Sort of back in Edinburgh for the first time in a few years. Used to work over in Codebase for a while. This is my first time at a PHP conference. It's my first time in about 15 years using PHP, but that's going to change in about 3 weeks because I'm moving jobs, and the new job, they use PHP very heavily in their stack. So the timing was quite fortuitous on this. So what I'm going to talk today about is the OpenFaaS platform and serverless with the OpenFaaS platform. And I'm going to focus on sort of how you can sort of get up and running very quickly yourself, just so that you can start sort of experimenting sort of with the platform and with serverless. And we're going to show you how you can do that with PHP as well. So the elephant in the room, yes, there are servers in serverless. This guy here is sitting in a room full of servers that are probably running loads of serverless platforms. Serverless is more about the architectural pattern. It's about a way of thinking about how you sort of break up your software, and it's another tool rather than sort of something that's going to replace everything before it. It's part of this like architectural evolution that we've seen over the years, where I don't know if you. Maybe some people still work with very large monoliths, but certainly when I did, we had one single sort of massive monolithic platform. And when you're working with it, it was nightmarish. If you needed to make a small change somewhere, then everything needed to be tested. It had massive knock-on effects. It became increasingly expensive and difficult to work with the bigger it got. And sort of over time, as it sort of more features went in, you would reach a point where people maybe didn't even know what certain things did. So we started to sort of break that apart. We were using like maybe the strangler pattern to sort of like pull pieces out and start implementing them in microservices. So you can kind of have more discrete, more sort of like contained pieces of functionality sort of in smaller services that are easier to test, easier to kind of sort of rationalize about. And functions are kind of the next evolution of that, where you're starting to sort of even get rid of some of the kind of the baggage that you carry with microservices. If you're running a microservice, then you have an operating system. You maybe have like, you know, some other sort of frameworks and components that sort of are required just to run your little bit of business logic, that when it actually comes down to it, you don't care about. You just care about your small piece of business logic being able to do what it's supposed to do. With the move to functions, it kind of hides pretty much all of that from the developer and frees you up just to sort of focus on the business logic. So what you've seen as well is, over the years, a change in how that impacts cost. You know, 10, 15 years ago, if you were building a service, you would sit down and you would think, okay, at the end of like 6 months, I'm going to have 10,000 subscribers, so I need, you know, this spec of hardware and this spec of sort of connectivity. But if the sort of service really takes off, I'm going to need to maybe double the amount of hardware to sort of have the overhead going forward. With functions and the business models that we've kind of seen emerging around those, they've moved to a pay-per-use. So you're paying for how much your functions are actually being used, which scales pretty much linearly with the sort of the actual sort of usage patterns. So this is what that looks like. You, at the start, have a big sort of expenditure, so you need all your hardware, you need all your VMs or whatever, and the line in red is the sort of the amount of traffic that your systems are handling, and you'll reach a point where, okay, I have too much traffic, too much for my current systems, so I need to get more systems. So you can't just bolt on a little bit, you have to spend another big amount of money to bolt on. So you'll see like pretty much half the time you ended up spending sort of double the money for the traffic that you were using. And moving to sort of like some of the serverless business models, you end up being able to kind of flatten that out because your costs are tracking the sort of the actual transaction rates. So what are functions? They're pretty sort of well-defined at this point, in that a function is something that's very short-lived. It's an ephemeral piece of business logic. You're not going to leave it running sort of on a port sort of for days, minutes, seconds is possibly long for a lot of functions. Doesn't bind to any ports. It doesn't have any state. That's a side effect of wanting to be ephemeral. You rely on external services to provide any kind of state that you need. And single purpose. It's your separation of concern to the absolute sort of like nth degree. You want to be as discretely focused as possible. So I'm not the only person that thinks there's something in this. This is a quote from Brendan Burns. He was one of the co-founders of Kubernetes, and he reckons the future of Kubernetes is serverless. And I think he means a couple of things with this. I think he's talking about two main things. He's talking about sort of getting out of the way of developers. You know, in the past, we had like platforms like Heroku and so on that you could use, but there was a big overhead. You had to learn how to use them, and you had to use them on their terms, which could put a lot of people off. Maybe it was you had to use languages that you'd no experience in, then the costs, they were still very expensive to run. But what you've seen sort of with Kubernetes and containers sort of has enabled a lot of this, and with functions, is that you can now write in whatever language you know, package it up in a container, and then consume it sort of with a transactional cost model. So it's not a magic bullet, it's just a new color. It's a new color in your palette that when you're designing your systems, you just have a new way of building your systems. You know, it's increasingly like a systems architecture sort of, it's of increasing importance to systems architects. So it's kind of exploding. The Cloud Native Foundation have a landscape which keeps track of everything in the all the tools in the Cloud Native space. This was it in December 2017. OpenFaaS is a little box in the corner, and we were in there, and there was like, what, 15, 16 sort of platforms. And this was less than a year later, probably 6 months later. It actually ended up having to have its own chart, and it's continuing to grow. We exist in a small corner of that, where it's like portable serverless platforms that you can put them wherever you want rather than being locked to particular vendors. And you can see sort of the growth over time. So sort of OpenFaaS kind of launched December, or well, 2016, 2017, and the growth has kind of exploded recently. So OpenFaaS, we've kind of three main principles that we've done, that we've sort of built the project around. We think developers are the most important piece of the puzzle, so we think about them first and foremost. We want operational simplicity, so you get that, or we get that by being mechanically sympathetic with the platforms that we run on. Don't reinvent the wheel. Use the best parts of what you're running on and use it the way that the platforms intended you to use it. And community-centric. We try to have a very sort of open and welcoming community. We're in that kind of crazy month of Hacktoberfest, where we have a load of new contributors jumping on, and some of the sort of the most prolific contributors in the last year are people that dropped in during Hacktoberfest last year. So the project originated in 2016. During DockerCon, they had a competition to see who could push Docker beyond its limits, and Alex Ellis, sort of the founder, sort of decided he would try and build something like Lambda, but with containers, with Docker. So it grew from that, and at the minute we stand at like over 14,000 stars across the organization, 145 contributors. We just won InfoWorld's Bossy Award for the second year running for Best Cloud Open Source Project. We're not the only ones, but we're up there with Helm and Kubernetes, like massive, massive projects. And like you can summarize it as, like, we like to summarize it as OpenFaaS being serverless functions made simple. So I hope I'll be able to show you that. So one of the things that you want is, you want to be able to try something as quickly as possible. You don't want to have to jump through a load of hoops and set up accounts and blah, blah, blah. So we try to make sure that it's as easy for you to get your laptop and get up and running. So you can deploy with Docker Swarm as your backend. So if you've like your laptop, you just sort of set up the cluster, you initialize Docker Swarm, one command, that just works for you. And then you clone the repo. There's like I'll send a link around later, but you clone the OpenFaaS repo on GitHub, and we have a script, deploy stack.sh. So you can run that on OS X, you can run it on Linux. We have a PS1 script. If you're running on Windows, you can deploy it on Windows as well. And you can see here what it's doing is it's creating a dedicated network for functions. It's setting up the configuration for Prometheus, an alert manager. So Prometheus is for capturing your metrics, which we use for like displaying your metrics so you can see what's going on. And we also use the alert manager part of Prometheus where you can use those metrics to trigger other events. So we use that to sort of auto-scale functions. And then we're installing the services, like 6 services. We've NATS, which is a sort of a message queuing system. So if for asynchronous sort of functions, it gets popped on a NATS queue. We have a queue worker, which handles putting things on and off the queue. Prometheus for the metrics, alert manager for taking actions based on the metrics. The gateway is kind of the core of the platform, but it's decoupled from the actual container orchestrator that it's running on. So you can see here that it's got FaaS Swarm because we're running on Docker Swarm. If you were to run on Kubernetes, there's a FaaSnetes for that. So here you can see what that looks like. The gateway is sort of the main ingress point for the UI. We provide like a simple management UI for managing your functions. We have a pretty rich CLI that you can do everything with, manage your functions, sort of create skeletons from sort of templates that we manage, or hit it via curl. And the gateway is then sort of obviously using Prometheus for metrics, NATS for queuing, and so on. But it then, depending on how you deploy it, it's using Swarm in the previous example, or it could be talking to Kubernetes, and it leverages natively all the features of Kubernetes, and then your functions actually run in that orchestrator. So it tries to be as sort of as composable sort of as possible, and these things just get injected when you actually deploy the platform. So this is what the UI looks like when you first set it up. I have a couple of functions sort of deployed down the side, or you can click on the button in the middle, and we maintain like a store. This is just, we have another organization called FaaS and Furious for functions. And you can just pick a function from that and deploy it immediately, or manually sort of enter your details. And then if you want to see what's going on in a function, you can see the number of replicas, which is going to be a reflection of what load it's under, the number of invocations that it's had, the endpoint, and so on. And you can then actually trigger it from the UI. We'll actually see this working in a few minutes. So what would it look like deploying Kubernetes? Is that much harder? Not really. We provide a Helm chart. Like Helm is like it's a repository for simplifying sort of the deployment of sort of software on Kubernetes. It's like Terraform for Kubernetes nearly. So you add a repo for our Helm chart, and then you install the Helm chart, you set your namespaces and so on. The service type is a load balancer, because in this case it was deploying into, I think, GKE. So if you have a sort of a hosted or a cloud Kubernetes sort of infrastructure, you use their native load balancers. So I'm actually going to try and deploy this so I can show you this working. So you'd like to say you can do it in 60 seconds. So I've checked out the repo here, GitHub, OpenFaaS, faas.com. If I do Docker PS, you can see I have nothing running. If I do Docker Swarm init, I've already initialized the swarm, but I'll deploy the stack. So I already have secrets set up for the admin account. Again, for secrets, we use the orchestrator's sort of own secret store. So Kubernetes secrets or Docker secrets. So that deploys there. And if I now go to localhost 8080, we can see we've got the platform up and running, and I'll deploy a function. I'll deploy, say, Figlet. And that's available now, and it'll take it while it's getting initialized. It'll pop up as ready. And I can go, hello. And you've got Figlet. And what's interesting about this is this function is a wrapper around Figlet, the command. There's no code here. It's just a wrapper around an existing binary. So if you have any binary, you can wrap it up and expose it. We have people who've been using it to sort of wrap up sort of internal tooling so that they can now expose it sort of more widely within the company, or even better, they can start composing with it in pipelines and doing things that were kind of previously sort of a bit more difficult to kind of pull together. So that was less than 60 seconds, so that was pretty good. So how do I create a function? Where do I start? This is one of the hard things with a lot of platforms where they kind of leave you hanging. You kind of get the simple stuff, and then you have to carry on. So we provide a load of templates. Thankfully, we didn't have to spend much time with this because a member of the community, Andrew Seymour, raised a PR adding a template for PHP 7. So we now have a PHP 7 template, which I will show you here. And we welcome contributions for new templates. So here what I'm doing, I'm using the FaaS CLI, and I'm creating a function called myFunction, and I'm using the language PHP 7. So that will pull down the templates, and we have a PHP 7 template. It'll create the function and tells you a little bit sort of about what you can do with it. So in this case, it's exposed the ability to sort of add extensions and to sort of add dependencies. So what that looks like is you end up with a myfunction directory with your composer, JSON, your PHP extension.sh, which is from the library Docker image for managing sort of extensions, and then source directory and the handler. And the handler is where it's a stub for your code. Myfunction.yaml is where you can configure things like limits and scaling and stuff like that. So what does the handler look like? Generally, it's pretty simple. Functions are the closest thing I kind of like to think of them as is POSIX commands. Their inputs and outputs are standard in, standard error, standard out. You know, it's as simple as possible. We do have variants in the incubator which expose native HTTP response objects or HTTP request, HTTP response objects, but most times you don't actually need that. So how do you build it? So we'll assume we've just left this sort of handler as is. So you can see it's handling the data object and it's returning it. So it's an echo. It's going to be an echo function. You build it with FaaS build, and you tell it where the function file is. So it's this myfunction.yaml that we just created. And that's now available locally in your image cache. If you want to make that public, so somebody else can use it, or you have an external system, you can do a FaaS push, and that'll push it up to Docker or K or sort of Google. And then to deploy it, simple, you FaaS deploy, and that adds the function to the running gateway. So in this case, it's deployed to one running on my laptop. And then if you want to invoke it, you just hit the endpoint with curl. So it's your gateway /function, then the function name, and you can also invoke stuff through the CLI. We have an invoke command that takes input from standard in. So that was a blocking example. Out of the box, without you having to do anything, your function's also accessible asynchronously. So this was one of the early examples where we had like a costly operation where you were resizing images. You don't necessarily want to block on that, so you're able to sort of invoke the function, provide a callback URL, and then when it's completed, you'd get your response in the callback URL. So what that looks like, the exact same function that we just created, the simple stub, the root changes to async-function from function, and you pass the X callback URL header with your endpoint, and suddenly you've got an asynchronous function, and you can do it through the CLI as well. So part of I kind of mentioned it before, containers has enabled the barriers to developers to kind of disappear. You use the language that's right for you, or even better, that's right for the domain in which your problem exists. You don't have to use the same language. And it gives you a way of packaging up your code so that you can build systems where you've got loads of different sort of languages. Maybe you're using functions from a third party or from some sort of public source. You don't need to worry about it because your interfaces are common across them. So chaining functions, this is the first of another live demo where this is an example of two functions that are chained together. One is exposing an app, which is actually written in Golang, and a backend classifier, which is a Python sort of pre-trained neural network. So I'll put that up later as well. That, if you want to check it out, is where this website is. So I'm going to first of all check. Yes, thank you. My mum will be pleased. And then what have we got here? Yes, it's a hot dog. That's brilliant. That's my unicorn company all sorted now. I can retire. So yeah, that's sample chaining. Jump across to GitOps. So GitOps is kind of everybody's been doing it in parts of this in sort of some form, but there's a realization that you have all these pipes that exist. You have like your code, you have like your CI and Travis, you have Terraform for something else. You have all these different tools, all these small pipes that do various things that are all glued together, but everybody glues them together independently. But when it actually comes down to it, like the only things that kind of don't change are your push to your repository and the push to production. So GitOps is about kind of closing that loop down. So your experience as a developer starts and ends at your Git push, and that gets it into production, and all the tooling gets built around that to sort of wrap it up into that sort of developer sort of workflow. So we have, so this is basically it. I think this is Weaveworks have been sort of pushing the term, and this is kind of how they see it. It's like, a declarative approach to provisioning and deployment. Obviously, your code is declarative as well, but you sort of describe in your repos where it goes and what it should look like and so on. Everything under version control, that's not new to devs, but it's something that sort of maybe a lot of sort of ops groups don't sort of have nailed down yet. Everything's made by change request. There's your audit trail. There's your kind of guarantee that nothing sketchy is going in. It kind of gives you immutability because you've only one route to get in. People aren't like SSHing on and doing things. Diff tools to detect any divergence and remediate. And then rollback and audit logs. You get all of that through Git. You can see what's going on. You can roll back a commit and so on and have your stuff pushed out. So yeah, immutability is kind of one of the nice things that you get from that by having everything sort of go through the repository. We can also run functions that are completely immutable. There is an option to do that as well, should you desire. So rather than sort of say, oh, this is a great thing, somebody else built it, the project have built OpenFaaS Cloud, and OpenFaaS Cloud is a GitOps platform that runs on OpenFaaS that's made up of serverless functions, and it sort of handles everything from your Git push through to sort of pushing to your OpenFaaS sort of platforms. We actually provide a hosted OpenFaaS platform for this. So the workflow is you write your code, you push it to your repo, you get a webhook event from GitHub for the push, and it goes to OpenFaaS Cloud where it packages and builds and deploys your function. And if you remove the app from your GitHub repo, it will delete everything and tear down the function and so on. So we try to, it's this idea again of mechanical sympathy. You try to behave the way that's logical for the tools and work with them. So OpenFaaS Cloud, it's portable. It's as portable as OpenFaaS. So you can run OpenFaaS on sort of Kubernetes, Swarm, Nomad. People have got it running on EC2, sort of actual EC2 instances instead of containers. I don't know why. Multi-user, so we get all of that from GitHub. It works on your GitHub orgs and your GitHub users, so you can sort of lock it down with that. Applies the GitOps principles. It's as simple as adding an app to your repo or to your organization. We provide nice feedback through GitHub, and we provide secure endpoints, and sort of everything's kind of secure through the platform. So it's as simple as adding the OpenFaaS community cluster to your org or to your repo. Then when you do a push, you'll get your status back. So you'll get a little tick sort of beside your commits to say, have they been tested and what state they're in. And if you say you want to dig in to get a bit more details, you can click in and look at the state, and you can actually get the build logs. So if something's gone wrong, you just see it in Git. You can see what's wrong. You can fix it. You can push it. It'll get repaired. We also provide a kind of a bespoke dashboard, authentication through, again, we use GitHub, we use OAuth. to sort of lock this down. And you can see what functions you have, what state they're in, the build logs for your functions, information about sort of how they've been invoked. So I'm going to show you a quick demo of that. So this is something I kind of thought of on the way over. I was sitting in the airport, and I was far away from the departure sort of screen. And it'd be nice to be able to take that information and sort of have it sort of accessible, you know, in an app. So I departed from Belfast. They have a lovely web page. I thought, great. They'll have like sort of an endpoint I can hit and get a nice bit of JSON. No, they return a bit of HTML, which is like, okay, that's cool. What can I do? So if you were consuming that in an application, you'd have to push all this sort of like translation logic into your application, which is kind of, you care about getting the data. You don't care about having to do all the translation. You've suddenly added all of this complexity that's completely unrelated to what your application's doing. So this is something where a function could be quite useful. So what I'm going to do here is I'm going to create a function that sort of translates it. So I'm going to do this kind of live in that I'm going to copy stuff across and show you what's going on. But I am going to push it to production. So I'm going to create a new function. I will call it airport. Yep. Got to be secure. OK. And there's a load of stuff in there because you actually have the templates directory in there as well. So first thing I'm going to do is I'm going to rename the airport.yaml to stack.yaml. That's because I'm going to be pushing it up to OpenFaaS Cloud, and it expects it to have the same name. Your stack.yaml is just the name of the function, gateway, and so on. If I go into airport source, or sorry, airport, I'm going to need a dependency. I'm going to use requests for for handling the HTTP requests. If I copy that, departures, departures. So you can see here, all I've done is I'm pulling in requests. And then if I go into source, I go handler.php. That's just your empty handler. Oh, OK. That's a CD, right? Never live code. OK, so copy that in there and replace that. And if we look at this, we'll just have a quick look at it. This is bad PHP. I do apologize for all you experts in the room. But so I'm hitting this endpoint, which I got from like looking in the developer tools, sort of on Chrome. Oh, yeah, ignore that, that error message. Sorry, I was quite late. It was quite late. I apologize. And it's using sort of XPath to sort of pull out the bits that I need from the from the HTML, and it's putting it in an array, and then it's sort of marshalling that to JSON, and it's returning that marshaled string. Yeah, OK. So I can build it locally, so I can go FaaS build. I don't need to specify the YAML this time because stack.yaml is kind of like a default. So that will build. Watch I'm like on time. FaaS deploy. OK, and then I can just hit this endpoint. Yep, got a JSON object back. Cool. Right, so I want to put that. That's great. It's on my laptop. Oh, I don't want to have to run this in production. I want somebody else to provide the platform. Brilliant. We've got the OpenFaaS Cloud. So what I will do is I will git add everything here. Function. And I will push that. So I've already got a repo set up here. So I'm just going to push that, and it'll prompt me for Okay, so that's pushed. So if I pull this across here, if I refresh, you can see the code's in there. If I look at the commits, you can see, oh, yeah, that quick. So if I hover over that, yeah. So you can see it's built it and it's deployed it. I can go in and take a look at the details, and you can see that there's your logs, everything's been built. And this is the actual endpoint. So I can hit that. And there, you've pushed that out, and that's accessible sort of publicly to whoever wants. Okay, so that's kind of an example of kind of how simple that flow should be in terms of getting your stuff out. You know, somebody in the background should be managing things like your auth and everything else, to secure the service. But as a developer, you just push out the functionality, and all those other things are layered on top. So, a bit more about Kubernetes. We talked about being mechanically sympathetic. Kubernetes, we have a custom resource definition. Think of it as a model of the functions that Kubernetes just knows about. It's a way it has of understanding OpenFaaS, and it plays nicely with all of the Kubernetes toolings. You then have an operator which works with these CRDs. It watches them, and it knows how to remediate change. It knows how to create them if they're not there, delete them if they've been removed, and so on. And what that means is you can suddenly work with OpenFaaS using kube control. So the native Kubernetes tooling, you don't see OpenFaaS. You just see kube control. And any other Kubernetes tooling, like if you're using Weave Cloud or something, it just disappears into the background because we've sort of leveraged the orchestrators natively. So I'll fly through these. So some examples of people using these in production. We've Anisha, sort of at the University of Washington, who is using it for processing sort of scans. So I think she's gamified the process of identifying anomalies in scans. And one of the problems she had with Lambda was the duration, the time it took for things to run was too short for what she needed, so she went to OpenFaaS. Lucas, sort of over in Contiamo in Berlin, they've built like a hosted data science platform, and under the hood they use sort of OpenFaaS for parts of that. And we have Patricio Diaz in in Paraguay, in Vision Banco. This is an actual sort of commercial bank, and they're using it in production. And some of the things they cared the most about were, metrics and sort of being easy to adopt and push out across the organization. And they're in the process of moving additional workloads. And if you're in KubeCon in Seattle, you can see Patricio and the project founder, Alex, talk about that sort of process of pushing it out to production. So another thing we have is Derek. So GitHub is great, but the granularity and permissions is it's too broad. You either have too much or too little. So Derek allows you to have very fine-grained control, and you can set up and control in the repo who can do what, and everything's done through GitHub comments. And we provide a hosted bot if your project would like to use it. So you ask Derek to assign a label. The user doesn't have to be a member of the organization. They do have to be a member of the organization, but they require no other permissions. You can get close where people are working on merging and basically everything that you can do with GitHub, and then you can just manage that in a config file, and that controls who can do what and the roles and so on. The list of users keeps growing. More and more people are actually using this in production, which is brilliant, brilliant. So what's happening next? Some of the new things that are coming along. Okay, you talked about functions. How do you get stuff into functions and stuff out of functions? How do you make it easier to have two functions developed by different people talk together? This is where the Cloud Native Foundation have started a working group for cloud events, which is around sort of normalizing what an event is, and then an event hits a function emits an event, and so on. So they've I think, the last time I was looking at it, they had like the 0.1 draft of the spec. Azure were kind of one of the first large clouds to add support. If you use Event Grid, you can have Event Grid emit events in sort of cloud event format, and we support it natively out of the box in OpenFaaS. So one of the examples we had was you drop an image into a storage blob in Azure, it triggers an event internally, which hits Event Grid, which emits it as a cloud event, which hits OpenFaaS, and in this case, we then pass it on to Slack, we process it and do a few bits and pieces. But what effectively you get with cloud events is you kind of don't care about what's coming in anymore. You can kind of handle stuff without sort of having to know everything. And then the next thing is you can pass it on, and somebody else can handle what you emit. Istio is another recent addition. This is kind of part of, people are increasingly caring about production and what's important in production, metrics, sort of knowing what's going on, control over the system. So Istio is an open platform independent, so you can run it sort of on multiple platforms, and it's a service mesh. So, and we run with Istio now. So a lot of the work was done by a guy from Weaveworks, Stefan Prodan. So the capabilities that you get from a service mesh are uniform observability. If you write a function, this works for VMs, it works for microservices. You can have everything under Istio. You write your service, you don't need to have metrics, you don't need to bake all this stuff in. It just gets layered on automatically on the side. In Kubernetes, your containers run in a pod, and you can inject what are called sidecars into a pod, which are just other containers which do things, which in Istio's case, metrics, telemetry, sort of security. They add a proxy which can kind of lock down traffic and stuff like that within the pod. Operational agility. I want to kind of redirect traffic to a new version of a function. It handles all of that for you. Policy-driven security. I need to sort of use OAuth or some sort of API key type thing to secure my endpoints. I don't need to do it. Sort of Istio can layer all of that on top and do that for you. So this is what Istio looks like in Google Cloud. Your traffic comes in through the cloud balancer, but then it hits the ingress gateway in Istio. So Istio kind of maintains its own set of proxies, uses Prometheus for metrics, Jaeger for analytics, or for distributed tracing. And is that minutes or seconds? Oh. OK. And yeah, it thankfully lets encrypt, one of the best things that's ever happened. It's baked in, so you get sort of SSL termination just happens. You just get it for free. And yeah, the metrics that you get are sort of just basically for free. Now, obviously, you would want service-specific metrics, and that's up to you as the implementer of the service or the implementer of the function. But everything else sort of gets bubbled up by Istio. The distributed tracing becomes especially important when, effectively you're dealing with just distributed systems these days, whether you're dealing with microservices or you're dealing with functions. It's a chain, and you're the one getting called because there's a latency problem, and it's never you. It's always something else that's slowing you down. But how do you prove it? With the distributed tracing built in by default, you can go in and you can actually look at sort of all of the sort of the components that have been hit and see all the latencies and see where your blockages are and dig in and sort of see what's going on at every point. And that just gets layered on by for free. So Istio is a project. It was originally created by Google and IBM. And it's open source, and I think they went 1.0 like a couple of months back. So OpenFaaS runs with Istio. The things that we find most useful are the mutual TLS between sort of all the components within the system. So everything's secure. Functions talking to the gateway, functions talking to other functions. It's all locked down. Only things that we want to see each other can see each other. You can't drop in a malicious function that's going to go and listen to other people's traffic. Sort of Istio kind of locks that down using the mutual TLS. And we also love the distributed tracing. It's just fantastic, and sort of the extra metrics that we get. We do provide sort of Prometheus metrics and dashboards out of the box, but sort of Istios are very good sort of addition to that. So there's a guide sort of available online that sort of Stefan's been working on. He's probably got a blog post sort of coming on that it's simple. Follow it, and you'll be up and running with a cluster, sort of running Istio and running OpenFaaS. And it's a really nice introduction. It's kind of sort of it explains everything as you go along. So it's a good introduction to actually seeing Istio running. So some of the operational agility, Istio lets you do Canary deployments. So you have your function that's GA'd and approved and out, and you've got your Canary function that tests want to sort of see deployed into production. You can deploy both, and then you can create what's called a virtual service, where you're exposing the function via this virtual service, and you can control how and where stuff gets routed. So the policy, like a simple policy would be like 90% goes to the sort of the production GA function, maybe 10% goes to the sort of Canary function. And you can use other things. The policies can sort of be impacted by other things. Maybe, I don't know, you only want one country or one region, or you have a lot of flexibility in terms of what you can do there. And there's loads more. It provides the ability to sort of do A/B testing for you. It provides sort of, you can layer on token auth, you can layer on OAuth 2. And these are all things that you effectively, as a developer, get for free. They're being done by the platform, they're being done by Istio, and it takes that off your hands. Another thing that we've got going, and this is probably the last thing I'll talk about, Fargate. So Fargate, I don't know if anybody has heard of Fargate. It's it's a completely hosted container platform in AWS. So it literally just runs containers for you. And one of the nice things about that is you only pay while the container's running. So you can deploy OpenFaaS in Fargate, and you literally are only paying while functions are running. And as of like a month or two ago, we actually introduced a component called the FaaS idler. And when you deploy your function, you can say, I want you to scale to 0. So you say you want to kind of leverage that with Fargate. You could have functions that literally are costing nothing until they're needed. They'll spin up, and then you'll pay for the duration that they're up before they get torn down again. So that's, again, community sort of contributed platform there. So one last thing, and I'm not going to go into detail on this. So I suggest you go to the website and take a look at the blog. Obviously, as PHP developers, you're kind of all sort of well accustomed to sort of microservices. OpenFaaS supports stateless microservices. So, you know, we talked about sort of functions not having ports and stuff like that. You can run functions that sort of bind to ports and are long-lived and so on. So there's a long blog post which kind of describes what we've done and tells you how to get started with it. And if you go to openfaas.com, you can sort of read more about that and check that out. So the only reason we exist is because people like me, people like other members of the community got involved. And it is quite addictive. It's a really interesting thing to work on. Really nice bunch of people. I've thoroughly enjoyed it. I would recommend it to anybody. If it's something you're interested in, you could join our Slack community. If you want to kind of really dig into it a bit more, we provide a workshop that you can go and just check out yourself, and it brings you through everything from installing all the way to using and operating, and sort of follow that at your own pace. You're totally free to take that, run it in your company, run it sort of in a local meetup or whatever. We've the blog, which sort of I kind of put together a month or two ago, where we are sort of putting up sort of kind of information about sort of anything new that's kind of coming in the project. Follow us on Twitter, please. And there's quite a few of us are going to be over in Edinburgh at the end of the month for the Linux Foundation's OSS EU conference. We're trying to get a meetup sorted, so there might be something pops up in your meetup calendar that you can come along and find out a bit more and chat to some more of the contributors. Swag, I have stickers. That's why we come to these things. So just grab me, I will give you stickers. We also, every Friday, we call it FaaS Friday. If you're using OpenFaaS, tweet a picture of what you've done with it, or tweet a picture of a screenshot of you just with the web page open. People have got swag for something as little as that. We'll send you out stickers. There's like T-shirts and sort of stuff like that. If anybody wants to take a picture, there's an invite open at the minute for the Slack group. So you can jump in there and join us. I can share this later as well. That's pretty much it. I guess if there's any questions, if you don't feel brave enough to ask here, just grab me. I'll happily sort of talk your ear off.
What's your background? I mean, if you said that you haven't worked with PHP before.
I come from like a physics and maths background, so didn't do computer science. Ended up in a telco company where I was writing sort of software for Ericsson switches in assembler. Kind of like, that was not fun. And then I moved into systems integration. So I got to see all the operations, all the infrastructure side of things, and you get to appreciate the pain there. And you also get to sort of, and then I switched back to development, and you kind of realize everybody's trying to solve the same problem. They're talking different languages, they're trying to do the same things, and I think that's what we're seeing now. People are realizing that, and everything's collapsing down so that people can just get what they need done. The last couple of years, I was working at Puppet for about 2 years, sort of working on like their new cloud products and sort of incubating stuff there. And I'm moving to an email security provider. Sort of next, they're going to be doing a lot of stuff around sort of moving workloads to Kubernetes and so on. But yeah, my background, Java, Go, bit of everything. I wouldn't consider myself a brilliant developer, but what is so nice about this is that you look at a lot of platforms and they're overly complicated, they're enterprisey, and if you want to try and understand them, good luck, because the people who wrote them probably don't understand them. The nice thing about OpenFaaS is that it's really, really cleanly architected so that you can go on and it's very easy to understand what's going on because it's very focused, it's very minimal, it's nicely sort of decoupled and sort of broken up. So even if you don't have, like, we use Go for all the service, for the core implementations. If you want to learn Go, it's a perfect project to get involved in. If you want to contribute more to sort of the PHP templates and so on, please do. We have incubator templates where instead of like invoking sort of the PHP each time, we'll maybe spin up sort of Nginx with like FPM and sort of have that sort of running to give you a faster response. So we need help there. So there's always stuff for people to do, and we'll help you out. Yes?
Excuse me, the event's being broadcast. Can you use the mic, please?
Oh, sorry. Sorry. Oh, time's up. Sorry. Come and grab me afterwards. Yeah.